Welcome to lesson number 2 on remainders and factors theorem. Today we will be doing a few examples. Now let us begin. Question number 1. If f of x is a polynomial of degree 4, when f of x is divided by x plus 1, its remainder is 2. When it is divided by x minus 2, its remainder is 8. What is the remainder if it is divided by x squared minus x minus 2? Now, if to find the remainder when it is divided by x squared minus x minus 2, we can write fx as x squared minus x minus 2, this is the divisor, times the quotient. Now it is given that the f of x is of degree 4. So this coefficient will be in the form of ax squared plus bx plus c. And the remainder, the degree will be 1 less than the divisor. So the divisor is of degree 2. So the remainder will be in a form of ax plus b, will be of degree 1 or lesser than that. Now, it is stated that when it is divided by x plus 1, the remainder is 2. Now, if we use remainders theorem, then f minus 1 will be equals to 2. Okay? Now, if we look at this properly, we can just substitute minus 1 inside. But actually, you look at this can be factorized, alright? This can be factorized into x minus 2 x plus 1. Alright, you don't really need to do that, but I do this so that you can, you can look at it in another way. So if you put minus 1 here, this whole term will be 0. Alright, if you put minus 1 here, it will be 0 as well. So you are left with, no, you put, this will be 0. So you put f minus 1. This part is 0. That means it will be left with minus a plus b, because x is minus 1. And it is given that when f minus 1, this is equals to 2. Let's call this equation 1. Now if you put 2, alright, into this equation, x equals to 2. Alright, so you put f 2. What will happen? It is given that when it is divided by x minus 2, it has a remainder of 8. Alright, that means f2 is 8. So you put f2, you will get 2a plus b. So you got 2a plus b equals to 8. Now let's call this equation 2. Okay. Now you use equation 2 minus equation 1. Alright. So we use 2 minus 1. What will you get? You get 3a here, and then you get 6. So you got 3a equals to 6. And a equals to 2. Okay. Now if a is equals to 2, okay, now you substitute it into equation 1, alright, you get b is equals to 4. So what is the final answer to this question? Now this is the remainder. So the remainder will be ax plus b, but a is 2, so will be 2x plus 4. We have come to the end of question 1. Let us move on to question number 2. Question 2, you are given the expression of two functions f of x and g of x, where p does not equals to q. Now they ask you whether x minus 1 is it possible that x minus 1 is a factor of f of x. Now let me copy down the two expressions first of the two functions. So you have f of x is given by x cubed minus 5p x squared plus 4p squared. And you have g of x. G of x is equals to x cubed minus 5q x squared plus 4q squared. Now you are given that p does not equals to q. Now part 1, they are asking whether x minus 1 is a factor, can be a factor of f of x. Now if x minus 1 is a factor of f of x, you will find that it is possible for f minus 1 to be equals to 0 if x minus 1 is a factor. So we need to check whether f minus 1 can be 0 or not. Alright. Alright. So let's put f minus, replace x with minus 1. So you have minus 1 cubed minus 5p. Now minus 1 times minus 1 squared plus 4p squared. What will you get over here? You will have minus 1 minus 5p plus 4p squared. And then you have 4p squared minus 5p minus 1. Now, you want to check whether this can be equal to 0. That means you want to check whether this expression have roots. Alright. So to check whether it has roots or not, what we can do is, we learn in the chapter of discriminant. Alright, we check whether the discriminant is greater than or equals to 0. So what is the discriminant of this expression? You will have b squared, we have 25 minus 4ac. Minus 4a, c is minus 1. And then you get 31. Okay, 16, you get 41, sorry. You will get 41. Okay. Now, so this is greater than 0. Implies that, right, there are roots. Alright, implies that x minus 1 can be a factor of f of x. Okay. Now let's move on to part 2. Now in part 2, it is given by that x plus k, alright, is a factor of f of x factor of f of x and g of x. Now if x plus k is a factor of f of x and g of x, that means f minus k will be equals to g of minus k, and they are all equals to 0. Okay, so let us replace x with minus k in each of the function. So what will you get? You get minus k cube minus 5p minus k square plus 4p squared will be equals to, now then g minus k is what? It's also minus k cube minus 5q minus k square plus 4q squared. Alright, they are equal. So you find that these two you can cancel off. Now this, they have the k, so maybe we can bring it across, and then this one we bring the one, those without the k, we can bring it to one side. So you have 5q k squared minus 5p k squared will be equals to 4q squared minus 4p squared. Okay, do you see something? They have something in common here. Now let me factorize and you will be able to see. Now take out your 5 and your k squared. Here you have q minus p. And here, alright, now you take out the 4. Then you are left with q squared minus p squared. And that can be further factorized into q minus p into q plus p. Now you are asked to find the expression of p plus q in terms of k in part 2 of the question. So you got q plus p here. So you cancel. Okay. So p plus q will be equals to 5k squared over 4. Okay. For that we have come to the end of question 2. Let's move on to question number 3. Question 3, you are asked to solve a given equation. Let me copy down the given equation first. You are given 8n cubed plus 18n squared plus 3n minus 2 equals to 0. You are asked to solve this equation. Now perhaps we call this f of n. Now first we need to guess the first factor. Normally we guess values that are, these are the few values you will put in and guess: minus 2, minus 1, 0, 1 and 2. Now look at this expression. One look, you know that all the positive values are impossible because all these are positive. And then this negative number is only minus 2, whereas all these number will be very large. So let's try f minus 2. F minus 2. Okay. You will get 8 into minus 2 cubed plus 18 into minus 2 square plus 3 into minus 2 minus 2. Now you press your calculator, you will find that this is equals to 0. Alright, it implies, according to factors theorem, implies that x plus 2 is, or n plus 2, is n plus 2. N plus 2 is a factor of f of n. Alright. Now, so you can express this expression as n plus 2 into a, or rather you look at it, the first term, look at it, is 8n cubed, right? 8n cubed. So your first, your coefficient of n square must be 8n square. Alright. Now the next one is quite hard, so we just put bn. Now c is also pretty easy. You look at this. This is plus 2 and this is minus 2. So the only way it can be is minus 1. Alright. Equals to 0. Now, why I know this is 8? Because you look at it, that's the only way to get an x cube. Alright. No other way. So it has to be 8. And this is the only way that you get a constant term. And given that the constant term is minus 2, this has to be minus 1. Now let's now compare the coefficient of n squared. So this and this will get an n squared, and this will get an n squared. So you have bn squared plus 16n squared will be equals to 18n squared. Alright, you cancel off the n squared. Then you got b is equals to 2. Okay, then you put b back. So now your equation can be written as n plus 2 into 8n squared plus 2n minus 1 equals to 0. Now this we can factorize. Alright, then we got n plus 2 into 4n minus 1 into 2n plus, this should be 4n minus 1 and 2n plus 1. Okay, you got 2. Yep, it's correct. Okay, now so n will be equals to minus 2, a quarter, or minus half. Alright, we have solved part 1 of the question. Now the second part, we are asked to solve this another equation that is given by 64 y cubed plus 72 y squared plus 6y minus 2 equals to 0. Now please take note, there is the word hence there. Now hence solve, that means you must make use of the first part of the results, alright, to solve what is required. Now you compare these two equations. You realize that this one you need to times 8 to get 64. This one you need to times 4 to get 72. And this one you times 2. Okay, to get 6. So by inspection, you know that n is equals to 2y. Alright, because now n cubed will be 8 over y cubed. Alright, 2 cubed is 8, so this is 8. If n cubed will be 8 over y cubed, you put inside, you substitute into here, you will get 64 over y cubed. Now let's check another one. Let's check this one. Now, you replace n with 2 over y, you get 6 over y. Alright. Now if n is equals to 2 over y, implies that 2 over y will be equals to minus 2, a quarter, or minus half. Alright, now you look at this one. Alright, so this one you will get y is equals to minus 1. So y is equals to minus 1. Alright, you got here as y is equals to 8, and this one will be y is equals to minus 4. Alright, now for that we have come to the end of this video. I hope you have a better understanding on the topic of remainder and factors theorem. Thank you very much. Thank you for watching. Please subscribe to our channel if you have not. And have a nice day.